Okay.
Hi, everyone. We have Alison here to speak to us about bridging data with design.
Thank you. Hi, everyone. Thank you so much. I appreciate your patience with the technical difficulties, but we are ready to go. So Angelina, Tiana, and Maddie, thank you so much for the introduction. I'm really excited to be here. Let's jump into bridging data with design and how it influences today's data products. And just a disclaimer at the beginning, I'd like to say that this presentation is completely independent of my work at Meta. All information that I present today is public knowledge, accessible from public sources and linked in the references at the close of this presentation. Okay, so today we'll start off by introducing myself and why I'm speaking with you today. We'll crystallize what you can learn from today's talk with the objective and the goal. We'll then clarify the context of this presentation by walking through the processes of data science and design thinking for us to keep in mind when we look at the 3 ways to scale your product's success. Next, we'll dive further into these 3 ways through examples from large tech companies. Finally, we'll discuss what you can do about it with actionable insights. And we'll close with a Q&A, so if you could please hold your questions until that time, I would appreciate it. So who is Alison? Hi, I'm Alison. I'm a product designer at Meta. I come from a background in data science, analytics, and fashion. I was once a fashion student in New York City who decided to become a web designer. I took several design and coding camps, then ended up teaching them for 4 years. I'm really passionate about empowering others to fulfill their career dreams. So outside of my work, I've taught and graduated over 200 UI design, analytics, and Python students. I love being involved in the community, so I'm happy to be a part of Women in Data. And I also sit on the advisory board for UC Irvine's Design Thinking program. I'm actively dedicated to lifelong learning, so I regularly take new programming courses to further immerse myself in tech. And in my spare time, I make little toy robots. This one, of course, so what inspired this discussion? In 2019, I attended the last in-person DataCon here at USC. As a designer turned data science student, I felt really inspired by the speakers here and set out to attend the conference these past 4 years now, including this year. Last year I spoke about what I'm really passionate about, which is the intersection between data and design. So my lecture last year was what data and design can learn from each other, which graduates us to this year, where I'm really intrigued by voice technology and today's data products that leverage this. So I'm here today to share my thoughts on how this intersection between data and design influences these data products through a few examples. And then we'll close with some actionable insights about what you can do about that. So taking us to today's goal and objective. So our objective today is to understand how to build effective data products based on the relationship between design and data, making our goal to be able to walk away with actionable insights that can improve your data product or understanding of data products. But let's narrow our scope a bit in the context of today's discussion by walking through the process from a high level of data science, just one process that follows the scientific method, and then agile design thinking. So data science is a field that deploys multiple techniques to abstract value and insight from data. Namely, data science tells us the what, and it tells us the what's next. So let's walk through a high-level view of how. So step 1, following the scientific method, you'll first be identifying your business goal. So the most successful goals that drive the most value are measurable, actionable, viable, and directly impact your business. For instance, a good initial goal would be to say, let's build an algorithmic model that helps us identify bad customers and good customers when assessing future customers for our business. Next, we'll establish your evaluation criteria. So what metric is going to provide us with the insight we need in order to accomplish our business goal? For instance, we want to measure the metric of how accurate our algorithm is. So step 2 is to acquire data and to start analyzing. So pull your data from whichever source, which is a process in and of itself, which I'm not going to dive into. Once you've successfully imported your data or your files, observe the amount of columns you have, the rows, the column names, etc. And taking a closer look, examine the individual column names. Is it clear what your data is looking at? Why or why not? Start with a high-level conceptual look at your data before you begin to dig into the specifics. It's important to have an idea of how everything is connected, even if you find your data to be particularly dirty or unclear. Then step 2A is to identify numerical or is your data numerical or is it categorical? What are your variable types? Is it normally distributed? If your data is categorical, or if your data is ordinal or nominal. So if your data is numerical and if your data is numerical, are your numerical values discrete or are they continuous? I recommend noting this info in whichever space your environment, which other space or environment or IDE you're using, for example, like the Jupyter Notebook, and then by commenting that note out with the hashtags. And then step 2B is to identify your data if it has any outliers. So in order to make proper calculations in your data, you'll need to normalize it as closely as you can. Getting rid of extraneous data points will help you structure your data from being too skewed, which makes sense. We don't want to base an average based on an outlier, right? And then finally, step 2C, which is identifying missing values or null values, and if there are any. So typically we use the mean, sometimes the median or the mode to give us the best values to fill in the blanks of our data set. And it's also important to differentiate if 0 is a valuable number within your data set or not. So next, step 3, we're going to split the data. So it's typically done as either an 80-20 or a 25-75 split, where your training set is the 75 or 80, and your test set is the 20 or 25%. You don't want to train your algorithm on everything you have. Your algorithm needs fresh, raw data to test from. So that's why we kind of save some extra for later to test. We use this sample to test the model on something new that the model hasn't seen before. We establish our predictive results based on the training set. And by comparing our predictive results to our test data set, we can measure the true strength of our algorithm. Which leads us to step 4, normalizing and cleaning the training data. So filling in missing values, the actual work that we identified in our previous step, the remaining outliers, which help us normalize the data that we're going to work with. And then step 4A, normalizing and cleaning the test data. So while this method can be viewed as tedious, it is considered to be best practice because whatever data you're training on needs to be similar and behave similar to the data that you're going to be testing on. And then step 5 is the fun part. It's the modeling phase, which we're determining which types of model we are going to use. And that's contingent upon the machine learning type we seek to apply. So we ask ourselves, is this a classification problem? Is this a regression problem? Or is this an unsupervised learning problem? Once we determine that, we can implement a model. And here you can pick 3 to 4 different algorithms that fall into your problem type. So I'm not going to break down every single algorithm within classification, regression, and unsupervised learning, but you can Google that or find that on Stack Overflow. Next, step 6, you're going to be training your algorithm. So with the selection you have from the above list, train the algorithm based on the training set. Leading us into step 7, which is also the best part, is making a prediction. So take the trained algorithm and make a prediction by applying your prediction to the test data set. So this is the part where you're finally applying the training section to the test section. And then we'll be taking that predictive result or output and analyzing it next, which leads us to evaluate. So we want to take the test result and compare it against the true values. The act of comparing your predictions against the true values is classified as evaluating your model. Once compared, we see how far off we are. For example, is the accuracy score metric, perhaps that could tell us how far off we are. And then if your evaluation is below your threshold, you should be happy. If your prediction results are extremely off, perhaps you're seeing an extremely high accuracy score on your first run. So you'll have to go back and check your data to make any adjustments. And then just to note and consider for our next part is this is also highly iterative and can be an iterative process. And then step 8, once we have the correct model and results that we're looking for, the accuracy score, etc., we evaluate. So we take the test result and we compare that to the true values. So the act of comparing your predictions against the true values is classified as evaluating your model. And once compared, we can see how far off we are. And that is similar to the point that I made in the last slide. Which leads us into the final phase, which is step 10. So put together your findings and analysis and communicate your findings in a way that will resonate the most with your given audience. So perhaps a keynote, perhaps it's a dashboard, even an email or just a presentation. Think about a meaningful way that encapsulates your findings and that's digestible for your business counterparts so that they can synthesize all the work that's been done. Okay, so that was data. And then let's talk about design. So design tells us why and lays out the interface to do so. And we begin by determining your business problem, people problems, and there's people encountering these problems, which are your users. This process in and of itself can be extremely iterative, hence you'll see the little revolving circle there. But you'll see this leads us to our next, and once that's defined, we gather qualitative, quantitative information about our users. We synthesize our user informations, which is typically in the form of people problems. And then we determine how we're going to best measure success, which is very similar to a practice that we partake in data science, which was the last methodology we just talked about, right? And then this takes us to the physical design execution process. So once we've determined really what we need to solve for within design, who are the people we need to solve for, we can start designing the interface in order to help our users solve their problem. And this is also probably the most highly iterative within the entire design process. And so we start by using grayscale for the sake of prioritizing our users' focus into the functionality and not the design. Typically, users will get distracted by the look, feel, branding, colorways, etc. We want to keep this as functional as possible, and we strip our first user testing of as much visual noise as we can. And then once we've addressed our users' feedback from that first phase of testing, we'll go back to our initial low fidelity designs and then boost them to a higher fidelity. So perhaps you work at a big company that has a bunch of design libraries and you could be copying and pasting over specific components. Perhaps you're doing this manually yourself. This is where you're adding color. Perhaps there's text involved. Perhaps it's just lorem ipsum. It depends on the context that your users need to see information in order to accomplish their user goal in the product that they're testing for you. And then once we've implemented that feedback, we can take ourselves to beta, which is another iterative process. So this is if your prototype hasn't been developed already, this is the part where an engineer will go and code the interface, the wireframes, for example, that they're given, and then put it into something called beta. Hopefully it's an MVP version, which is the minimal viable product. It focuses on the core functionality of the problems that you're solving for your users, and that's what gets tested. And that's super important because the most valuable information you're going to get from your users is when you actually put it out there. So once you deploy it, that and having it mapped out in your design process in the very beginning stages. So you'll see in that first kind of circle there, knowing in advance what problems are we trying to solve, and then what's the best metric for success? How are we going to scale and measure our user interactions with our product moving forward? Should we have a feedback bot? Should we have feedback buttons embedded into our product? Are we using certain Google Analytics? How are we tracking how our users are interacting with our products in a quantitative way, right? But then we also want to entertain a qualitative way because we're going to get additional feedback from our users when they actually talk to us. And then matching that qualitative data with that quantitative data, that's what's going to give us the best insights. And then there can be a lot of talk about this because research can just be an iterative process, right? But you kind of get to a point where go back to your people problems, think about the problems you're really trying to solve when you've triaged what your people problems are. And then if you've hit that and it hits your success metric, then you're good and then you can move on. And so taking a step back and looking at both the design and the data processes, we can see that there are some similarities here, right? So both follow a process of validation where as more information is learned, you're informed and you're able to make better decisions, which makes sense, right? And as you make a better decision, and you make a better decision when you have more context on the problem or the opportunity. But ultimately, these fields and the people that work for these respective fields are separate because they ultimately produce different outputs. Your data scientist, for example, is more focused on generating an algorithm, and your designer is more focused on making the actual interface. But how do we do this? And more importantly, how do we do this right? So there's 3 ways that we're going to discuss about how to scale your product's success. Sorry. So your data project, first to note, it's only as good as your ability to do the following, and then we'll talk about why after. So number 1, and this is probably the highlight meat of this entire topic here, is feature value. So which features are we actually providing to our user, and are they really useful? Do our users really need them? So consider the context of your product. So what might your user want from your product? Circumstantially, physically, what is your user doing? Are their hands occupied at the moment because they're holding a child in a grocery bag? What constraints might they have when they're using your product? Do they have cell service or Wi-Fi? How might that affect your product, and how might that make it more useful or less useful? This is where we apply design thinking to flesh out the right features at the right time for the right people. Next is interoperability. So here we question how well the product talks to other products. And this can be internally or externally. So if I'm using a certain smart speaker in the kitchen, and I have sticky hands from a treat that I'm making, and I want to play a song while from my cooking playlist on Spotify, but I don't want to physically have to touch anything. Does my product a lot for me to do that? And does the product that I'm trying to talk to, does it talk to the product that I need it to? So for example, I want to play a certain song on Spotify. If I'm talking to a smart speaker, does my smart speaker understand the application of Spotify, and it can actually open it up and take commands from it for me? Or does it only recognize internal applications? And that said, another example is, what if I'm cooking and I'm running out of an item I'm cooking, but I want to order it again as soon as possible because I'm having guests this weekend? Is my product able to take a command from me to buy something? And how do I know that it's going to buy the right thing? How do I know that it's going to charge the right card? And so in order for it to do so, this is how we bridge data with design. So the technical capabilities within data science, matching with design thinking. So putting our user first, thinking about their circumstance, and giving them the ability to do so with their needs in mind. And so that this user, in this example specifically, can purchase an item. And then third, the other really important product, or the other really important way or method in order for us to make the best or most effective data product, is the product's ability to democratize contributors. So consider what types of users are using your product. What might they need to be able to do? What is the most effective way for you to train your data product to be able to do that? So a successful enterprise product is a canvas of opportunity. For instance, take a linguist, and this is someone who studies languages and doesn't necessarily code. This person could be the most effective creator for advancing natural language processing or natural language understanding, which is a process where you allow basically your smart speaker to interpret and then respond to the user based on what they say, while understanding the intent and the exact command of what they say. But the smart speaker only understands code if you're programming this functionality, right? So what do? How do you enable a non-programmer to effectively and even perhaps autonomously contribute to the value of this data product without the need of an engineer and without breaking anything. Perhaps you can bridge data with design to create an interface to allow for this effective collaboration. So how might we achieve any of these points that we just talked about? Well, let's look at a couple of examples from some major tech companies that you've probably heard of. Specifically, again, we'll be looking at the assistant voice technology within the data product space, specifically hardware. And then to note, this is not a ranking of who did best. This is merely a public analysis on how 3 companies are addressing the 3 points we just brought up in our last segment. Okay, so let's take a look at Google and specifically the Google Home. Meta, specifically the Quest 2 headset and the Ray-Ban Stories products. And then Amazon, who kicked off voice tech products with Alexa Assistive and is currently using Alexa here in the Echo. So first, Google has a suite of products that leverage both data and design thinking to effectively address their users' wants and needs. So they have a collection of hardware and software that talks to each other. And that reminds us of the interoperability that we brought up in our last segment. And then more on interoperability, and this actually reflects on 2 and 3 conditions, so that and also the basis of contributors. We can see that Google's products contain valuable features that are interoperable with external products. So if, for example, say a user is on their Google Home and they want to check their connected Nest device to modify the temperature or to get an alert that someone is at the door using voice technology. So this is possible because these products, even though Nest is a company outside of Google, they have a relationship where they can understand each other and talk to each other, which makes for a super valuable feature. Again, feature value, which we talked about in our last segment, and that's what will make this, and in getting this right and improving this is what will make this a more successful product, right? Because the more valuable you can make a feature in a product, the more people are going to enjoy it, download it, use it, buy it, etc. And then this goes to our 3rd condition, which is democratizing contributors. So Google has an entire suite of software applications publicly available on their developer website, and that allows anyone to further customize their experience with any Google products. So it's a developer website. I'm sure a lot of you are familiar. A lot of major tech companies have them, and then they allow, no matter who you are, what coding experience you have, there's all these different types of courses, documentation, even news, and it tells you how you as a non-technical person can customize features within a smart speaker that Google makes. And then similarly, Amazon has a suite of products. The Echo is a product that talks to thousands of applications, allowing you to add things like to your shopping list in our previous example, meditate or queue up a song using a third-party app. Amazon also democratizes their contributors by having multiple learning platforms. This is the same kind of concept developer website as Google has. This allows, and what's really important about this is for different types of experts to contribute to customizing features. So your product is only good as people can make it. If you make it easier for a certain expert in a certain field to be able to contribute to a tech product, you have the ability to make it into something you can never even imagine, which is a positive thing. And then 3rd, Meta. Meta also has a suite of products and a new environment that we've probably heard of to use. So we'll specifically be, in this example, talking about the Ray-Ban Stories glasses and the Quest headsets. So Meta's products are connected with Messenger, so you have the ability to message a friend from your sunglasses and then listen to music from a third-party app, and then take a video of you soldering something, or I did it with a ceramics class, or doing wood shop. But let's also consider that as users are getting more excited about these data products and they're bringing them into different environments, think about the technical constraints that come with that challenge. Think about the noise in that room. And the entire point of assistive technology is to pick up noise. So how is it able to differentiate the noise that it needs to hear from your user intent, from what your utterance, what you're saying, away from background noise, or if someone was yelling in the background. And so that's just about making the technology as robust as possible, data, and I can't really get into that, but making the data more effective and able to inform more decisions. And then again, this example reminds us about how, and then the other example is the Quest headset. And a really cool opportunity within this is it's able to empower people perhaps with certain dexterity disabilities to use voice commands without having to use their hands. So it makes it easier or lessens the steep learning curve. In this example of piano, you're able to see the notes virtually kind of run across the piano while you're learning to play. And then this example reminds us that products are only, again, as powerful as the contributors, so us, as we allow them to be, and our creativity. And the value of this product is determined how smoothly we integrate the needs of our users matched with our tech constraints. So again, bridging data with design. And then just like Google has, Amazon has, Apple has, a lot of major tech companies has a developer website. And this is super important again, because it's democratizing the amount of contributors. Again, if you make it easier for people to understand how to contribute without technical experience to a tech product, you have an entire open canvas of opportunity to invent new things, right? And then if you even, for example, go on Alexa SkillKit's website, so the developer website for Amazon, it has an entire showcase of hundreds to thousands of success stories from people who just say, hey, I want to make the weather more actionable, or I want it to sound different. So I'm going to go on this website, I'm going to learn, going to take this course that they gave me for free, or the documentation for free, and figure out how to do so. And then you can monetize that and turn it into a business. And that's what makes these products so powerful, is their enterprise opportunities. And then interesting, just me thinking about, okay, how might this influence human behavior, and then what could be on the horizon for us? So let's also consider how these companies sunset and then introduce products. So again, I said, as in the developer websites, they also act as a news source. There's videos and documentation, et cetera, that tell you when a certain feature is no longer available, which drives us to think, why is that feature no longer available? Like, is there something they want us to do else? Do they want us to use more Android products, for example, that have screens instead of just using our voice? I got that from the news alert that Google was sunsetting just voice commands in the last year. So that's where that came from. But again, each company has an ecosystem of data products, hardware and software that engender one another. So 2 examples really quick are Apple, which is advertising. They had a billboard about it recently, up to 10, I think, about AirPods now can allow for spatial audio. So which drives us the question, which contributors would use that? How would they use that, and why? And why is Apple introducing this technology to us? What might be next? And then another interesting thing on the horizon is Meta. So they introduced this feature, and it was actually in the context of an Instagram filter back in April, which showcased an elementary version of a new type of technology called depth mapping. I can't say that word, mapping. And they decided to introduce it through Instagram. So a bulk of their user base uses Instagram, and they're able to introduce like a small portion of that technology, get people using it, playing with it in a super accessible way, right? You just access a filter through like a couple of buttons. And then it gets people thinking about it, and it introduces people to this idea of, okay, how would I use this technology? What could I create out of this? What do I want to do next? And then that thinking and then the action following that thinking is what's going to make this product grow in sophistication. This is kind of, to make a quick fashion reference, this is kind of the same logic. If you're going into a store and you're buying a $30 bottle of perfume, or even a pair of sunglasses, you're spending $30 to $300 and you're buying into the brand, which actually contains an entire ecosystem of products that could stretch to several $1,000 purses to tens of thousands of dollars of products, right? But it's just introducing you to the ecosystem, getting you to think about it, getting you involved in it, so that you can eventually be thinking about other things that exist, and maybe you'll buy them. Not a dark thought, it's an opportunity. And so here, if we go back to Meta's depth mapping thing, let's think about what they were doing with that. So they introduced it in April, and then they came out, and this was on TechCrunch, that they had these risk products that are rumored to be able to pick up and decipher your motions. So let's think about how they first introduced us this tech capability of being able to feel, right? Being able to sense and having a UI that can sense its surroundings, which is kind of like AR. And then they take that another step further by rumors of rollouts of products that are going to be, of course, separate products that kind of are engendered by the same tech logic, right? So you can feel and you can physically interact with the technology. And then how well they bridge data with design to accomplishing these three things is how they determine your product's success, which is the point that I made earlier. And so what does that mean? So what the tech can do and what the users need, addressing that, and being aware of your scope and the exact problems you're trying to solve is what is going to make you create the best product. So you have all these technical capabilities available. You have so many different types of users you could satisfy. Being able to hone in on your scope, figuring out which problems you need to focus on. Perhaps you could do this through like an impact effort exercise, figuring out, okay, if I want to accomplish this people problem, and it's going to take me X amount of impact, or it's going to take me X amount of effort from a design perspective, from an engineering perspective, that also factors in cost. What kind of impact is that going to have? And then I produce this feature. And then how is that impact, that feature, how is that going to be used by our users moving forward? Is this scalable? Are people going to see this and be inspired to turn it into something else, which again grows the opportunity for your product's value to expand. So all this said, so what? Like, why should you care? What does this mean? What can I do about this? So here, everything said, let's have 4 actionable takeaways that close everything that we just discussed. So things that you can do right now are 1, utilize these core elements, these 3 steps that we talked about to push your product to the next level. And again, those things were interoperability, democratized contributors, and feature value. Again, the most important things you should be concerned about when thinking about, is my product going to be successful? And then next, consider how the major tech companies are approaching these elements. How is Apple and Google democratizing their bases of contributors? They have all of these developer websites, right? How might your product, how might your company apply similar logics, whether you have the same resources or different resources? How are you going to adapt to that based on what the bigger companies are doing? And then also consider, what are they changing and why? 3, your product will only be as successful as you allow your contributors to do so. So again, this goes back to, if you want your contributors to be able to enhance features within your smart speaker that you're putting out to the world, what interface, how are you teaching, or how are you displaying or sharing documentation about your product that teaches your users what they can do with it? What is your creativity landscape look like? And then how is that scalable? How is that maintainable as things get expired, as things break, etc.? And then finally, uniting data with design processes by championing collaboration in the infancy stages of your product development will also drive success for your product. So thank you very much. These are my references from today's lecture. And does anybody have any questions? Yes.
How do you think about it when there's like, maybe, especially like in text code?
Okay.
We can hear you though. It's a good
Yeah.
How do you think about it when essays where there's the potential conflict where we want to this competitor offers a product that creates other people's different products? We want to let people watch TikTok videos, so YouTube videos. Perhaps for that, that's the case. Real videos, like
So if I'm understanding correctly, your question is about making a product more useful given its ability to have all these other features that come from external products that are housed within your product, or?
I guess it's balance like the desire to create.
Right.
Spaces is the place where the most useful product in one space. And you mentioned even this is Spotify for your
Right, but like not to call it Apple, but you can't do that on an Apple speaker, for example. They lock you into Apple Music.
I don't think I don't think Siri would be up. I don't think that.
Yeah, did that answer the question or was there a follow-up?
Or just like how you think about, or how our companies think about like to I guess when we say
Oh, so like if you have an internal application that does something, but then you have an external that behaves. So I think that's a great question, and that points to scale. So the people that own, well, I first wanted to say that the people who own the product have the upper hand, right? Because their the user base is, the user is using this data product in order to access the functionality or accomplish their user need that they want. So I think it depends what is the interaction by which that your product offers that and the value of that weighed against what that other product can do. So in our music example, Spotify. So I don't know the exact legal things, but Spotify has something called car thing, where you can use your voice to command to call for different songs. But that product is very much designed to stick in your car, and it's very much called car thing. It's not like its own Spotify speaker. So I'm not sure what, I mean, maybe they will come out with other products that we don't know of, but I think the understanding the value of, I mean, if I'm able to call a song on Spotify and I really enjoy this feature because I'm physically able to talk, I'm able to talk to something, that feature comes from the data products, not necessarily from Spotify. So I think it's a measure in a way of value and cost and impact. So if the major feature value is coming from your data product, then you know that you're in the clear and your product can be more successful. So Amazon wants to make their products more and more robust, to understand the nuances in your tone and what you say, because when you command something, it could mean a bunch of other things. There's TV shows that have the same title as a movie, that have the same title as a song. And the only way that they're able to differentiate that is having better data, right? And so I think if you're thinking of, the internal application, like the software that's in it versus the hardware, it's where does the feature come, and then and if the majority of what the user is enjoying is within that, like within Spotify itself, then maybe you go back and you talk to your users and you figure out what else they want, what else they need, what can you add or take away or whatever from your product. But that answers your question. Yes.
Hey, Brian Collins from Accenture. I'm curious on your view with respect to maybe some of the unintended consequences that some products may have. Products or unintended consequences, issues with things along those lines. So, with respect to trying to get the broadest amount of users, understanding that, but also weighing some of those unintended consequences that you don't understand how the organization will move forward in the personal business.
Well, I think part of my answer comes from some of the terminology you even use. And I actually had this conversation earlier today, so I'm very glad you asked it. It's a sticky area, right? And it can turn dark very quickly. we're talking about data privacy, we're talking about all ages. And ultimately, ultimately it's value versus cost. Your users are going to use your product if it gives more value than it costs them. And I don't want to say that's an excuse for extending or gray lined data privacy laws. And that's not the scope of my discussion and what I'm directly familiar with. I'm sure there's way more experts than I. But when we're talking about making the best product for a user, it's understanding all of their needs and their pain points and considering those to iterate your product so that it becomes the most valuable thing and helpful. It's supposed to integrate seamlessly into someone's life and improve their life. But yeah.
Great, thanks. Just to kind of follow up, I guess, is that the same idea around like, the Instagram model and this application, not specifically for when you're deciding to kill that project? If you can't, if you haven't decisions.
So it's not my department, it's kind of out of scope of like the lecture here, but ultimately I think our goal as designers, as creators, is to consider where our users are coming from and act in good faith. And there are many different organizations that relate to kind of this that I think can combat that better, but yeah, thanks.
Hi. My name is Christian. I do data visualization for gaming, and I kind of want to go back to your slide where you're talking about the Venn diagram between design and data analytics. And I wanted you to rehash maybe like what were those similarities and what can we learn from maybe like in a sentence, like what can we learn from that the way that these two things are together as far as like design and data analytics?
Great question. So the point that I was making is how there are so many similarities between the process that we go through within data science and within design thinking. The big idea is that these are two different disciplines. They have different types of employees, they have different types of training, they get different types of degrees, they have different types of outputs, but they follow very similar practices, and ultimately they have to work together because they have a common goal of making the best product that they can. Whether you're coding an algorithm, whether you're designing an interface, it all culminates into one data product. And so I think with that in mind, thinking in one way to consider this is, again, is in the infancy stages of your product, being able to have an open discussion between designers, between research, between data analysts, and that collaboration is where you can ask questions like, what does it mean to have null value in this data set? I see it represented on this dashboard I'm designing here. Does it happen often? Oh, I see a negative value. What does that really mean? Having designers ask those questions and not being scared of data, I think is super valuable. And of course, there can be concerns of this could be continuously collaborative and when will it ever stop? But and that goes back to like laying out our objective, laying out what the real problems we're trying to solve. And then using the time that you have, that collaboration time, in the most efficient and effective way of saying, okay, well, if I know that there's null values, if I know that there's zeros, then I can design this card or represent this percentage in a certain way, and then move forward. But say I didn't know that zeros also represented null values in this data set, and then I had a visualization that represented zero, and then there was zero representation that represented a null value, when those could have been the exact same thing. So having that communication and understanding is super valuable. So I think even going back to your data analyst, and you're understanding, okay, these designers are designing this application, there's all these nuances and intricacies within the data. They should really know why the columns are named this way. And it's really important from like a data cleaning and aggregation perspective when we're analyzing what's happening on the screen, to keep the column names, for example, the same, or even like the case lettering, you know, the attributes, etc.
Got it. Can I see the slide where you had both of them on there?
This is just design thinking. This wasn't data science and design.
Oh.
But yeah, design thinking, I actually do have a Medium article about that walks through data science, and I can send you a link to it.
Sounds good. Thank you so much.
Yeah, you're welcome.
Hi, I'm Maria. I had a question about the design function and getting your input to improve the product.
Mhm.
So in the beginning, you use beta test and limited test capacity to see that feedback. But when you're looking at continuous improvement over its life cycle once you release it, and you're allowing that sort of development and user customization, how do you track what you're wanting to improve on later companies?
Great question, thank you very much. First starts with knowing from the very beginning of how you're going to define your success metrics, and what things you want to look at. So say there's a particular user flow, that's the basis of this product, is the user accomplishing a certain flow. Maybe you're looking at the time that it takes from a user to get to this page to this page. Maybe, so it depends, like what information are you trying to get from your user, and then thinking about the most non-destructive way to gather that back from your user. So yeah, the example of a feedback bot or built-in questionnaires that pop up in the modal window that you can click away. There's different types of strategies you can deploy, and also why not try multiple and see what interaction rate you get. Perhaps you created a new idea for a certain type of feedback gathering thing, and it works better in that year than it did than the other score did in an entire half of a year. So always entertaining new things, but knowing exactly what information you collect from your users is important, because you need to condense the questions you're going to ask, right? So I hope that answers your question. Yes, in the white shirt. Yes, hi.
I think I can do it.
Yes.
When you're introducing a product, talk about
Mhm.
you're looking at the politics. How are you defining
So the qualitative metrics, you can collect them from your data, right? Conducting sentiment analysis. My example was specifically within design, and what I had in mind was there's all these different research methods, and we're very aware that there's several different types of biases for research. And the point is that when you take multiple different types of feedback, the qualitative and the quantitative, and you move it together, it paints more of a picture, right?